Okay, guys. Quadratic formula, it's on here. You need to memorize it as soon as possible. This is section 3.4. It's on page 62. This is all about the quadratic formula. We're also going to look at something called the discriminant. The discriminant is the value under the radical in the quadratic formula. Right here's the quadratic formula. Under the radical is b squared minus 4ac. That's what we call the discriminant. By knowing the discriminant, we're going to know some things about the solutions to a quadratic. So it's very important that we understand what the discriminant is. Some things to notice. If we're going to use the quadratic formula, the equation must be in standard form. It must be set equal to 0 in order to use the quadratic formula. I'm going to show you where the quadratic formula came from. If we're given ax squared plus bx plus c equals 0, don't write this down, just watch. First of all, I'm going to complete the square. I have to have a 1 in front of here, so I divide through by a squared. I'm sorry, by a. Okay, that's the first thing. Don't write it down, just watch. If I'm going to complete the square, the constant goes over to the other side. I have to take half of this. What's half of this? B over 2a. So if I square b over 2a, what do I have to add? B squared over what? Not just 4a, 4a, and I have to add that to both sides. All right, so now I'm going to factor this. It has to be a perfect square. I do the square root, this sign. What's the square root of this, guys? B over 2a, right. Equals plus or minus. Now, what do I have to have here to be able to add these? Common denominator. So I'm going to have to multiply this by 4a on the top and by 4a on the bottom. So now I would have this. So look at what I've got over here. I've got a b squared minus a 4ac, and what's that all over? 4a squared. This is quantity squared here. Oh, why did I put that? I don't want that yet. Now what do I have to do? Take the square root. So I have x plus b over 2a equals, now the plus or minus, the square root of b squared minus 4ac, and I can take the square root of this. What is the square root of 4a squared? 2a. And now I would just bring this over here, right? So I have x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. See how we have a common denominator? So this is the same thing as negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? That's where it comes from. I don't expect you to do that. I just want you to see how it all works out. Did some of you have teachers that made you rewrite this over and over so that you would memorize it?
No, but we did. There was a song that she showed us.
Do you want to sing it?
No.
No, wait, what is it? I'll sing it.
Okay, it's to the tune of, I don't know what.
It's like all
Ring Around the Rosie, maybe? I don't know.
It was like all over 2a.
Yeah, it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That would sound a lot better if I didn't have a cold. Just kidding. All right, there's how we get it. Memorize it, know it, sing it, whatever you need to do. All right.
I just like when we play it like at
at the end of the day every day.
Oh, I
Until
love
we all knew
that.
it. So now it's-
Oh, I'm going to have to
Our
find
teacher
it.
was terrible and didn't do it. He was just listening.
Well, that's okay. That's all right. Okay, well, maybe we'll sing it every day until everybody knows it. I'll make you guys sing it. I'm not singing it anymore. All right, analyzing the discriminant. Here's our next part, guys. If we have this right here, b squared minus 4ac, that's that discriminant part. If it's larger than 0, meaning if it's positive, we're going to get 2 real solutions. All right, we need to know this. If b squared minus 4ac is equal to 0, we're going to get 1 real solution when we solve, and 1 x-intercept. Here we get 2 x-intercepts. If b squared minus 4ac is negative, we get 2 imaginary solutions, no x-intercept. All right, we're going to solve these now so that you see this. Okay, so to solve this, I'm going to have to get it into the right form. We're going to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, you could get out a calculator if you needed to, but I'm just going to do this. I have a negative times a negative, that's a positive, that's 40 and 32, that's going to be 72 and 49, that's 121. 7 plus or minus the square root of 121 over 2. What is the square root of 121? 11. So we have 7 plus or minus 11 over 2. What's 7 plus 11 divided by 2? 9. And what is 7 minus 11? Negative 4 divided by 2 would be negative 2. Look at the solutions we got. These are 2 real solutions. What about under here? What about that discriminant? Is it positive, negative, or 0? Positive. Go back up here. If it's positive, we're supposed to get 2 real solutions. Did we get 2 real solutions? Yes. Okay? All right, let's do the next one. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm just going to say it a million times so you'll know it. All right, so now we've got 4 plus or minus. Anybody know what's under there? Can you do it real quick? What's that discriminant? 40. Okay, looking at that discriminant, it's positive. What does that mean we're going to get? 2 real solutions. Just like over here, we got 2 real solutions. And it's all over 2. We're going to split it up now. So it's 4 over 2 plus or minus. How does radical 40 break down? 4 times 10, so what would it be? 2 radical 10. So this term's over 2 and this term's over 2. So what are our solutions then? 2 plus or minus what? Radical 10. Those are our 2 solutions for x. Are those real solutions? Yeah, it's irrational right there, but it's still real. What's radical 10 about? Is it closer to 5 or is it closer to 3? 3. Square root of 9 is 3. Square root of 10 might be 3.1, 3.2. Okay, so we have those 2 solutions. All right, let's do this one. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What's that discriminant going to be this time? 0. What does that mean? Look back up here. 1 real solution, 1 x-intercept. So we should only be getting 1 real solution here. So if I have 6 plus or minus 0 over 2, what's my one real solution? 3 is the only solution there. That's going to be the only x-intercept is that x equals 3. All right, let's check the discriminant here. What do you think the discriminant is going to be based on what we've done so far?
0.
We've had a positive, a 0. Now we're probably going to have a less than 0. Let's see. Okay, instead of dealing with these really large numbers, what could I divide every one of those by evenly? 2. That's just going to make my numbers easier to deal with. So x equals negative b. Everybody understand why this turns into a positive 6 when I do negative b? Because it's negative and negative. Plus or minus the square root. B squared minus 4 times 2 is 8 times 9 is 72. All over 2 times 2 is 4. What type of number then am I going to get under that radical? A negative. So I have 6 plus or minus the square root of negative 36 all over 4. So because that discriminant's negative, I'm going to get 2 imaginary solutions. How many x-intercepts are we going to have then? No x-intercepts. So my solutions are going to be 6 plus or minus 6i all over 4. What does that simplify to then? Put this over and reduce it. 3 over 2 plus or minus. What's another name for 3 over 2 as a decimal? 1.5, right? I want to show you guys something that's really cool that you're going to have the option of doing. That you can't do this yet because you don't have the program. Everybody watch. If I go on my calculator, I go to program. I took the time to program in the quadratic formula. So when I hit enter and enter again, it's going to ask me what's A. A is 2. What's B? Negative 6. What's C? 9. And it tells me my solution would be 1.5 plus 1.5i and 1.5 minus 1.5i. If you can program this onto your calculator, you are allowed to use it. Yes?
How do you do that?
Well, I'm glad you asked. If you go to Canvas and you look at today's calendar, there's going to be a link. The link contains either directions written out step by step, and it also has a YouTube video that has the directions both with a video, you know, and sound and everything. So whichever way you want to do it, and you can use it. So you can use this at any time. It's great to check your work with. See, look, I could even go back up here. Let's say I didn't feel like I factored this or used the quadratic formula correctly. I just go to my program, enter, enter. My A value is 1. My B is negative 7. My C is negative 18. Boom, there's my solutions, 9 and negative 2. All right? So it's great to be able to check our work. Now, it's not going to work so great on this one, though. Do you know why? Why would it not work so great here? What kind of answer did we get? Yeah, that's an irrational number there. So watch what it's going to do if I use it for this. I can still check my work, though. So I have to put in 1, negative 4, negative 6. Here it tells me my solutions. So now I'm just going to check. Is that what 2 plus radical 10 is? Yeah. Is that what 2 minus radical 10 is? Yes. See how it allows me to check those answers. All right, so great thing to have. Make sure you take the time to do that over the weekend. All right, over here now, we're just doing one more problem down here at the bottom. So we've got a baseball player. He hits a foul ball straight up into the air from a height of 4 feet off the ground with an initial velocity of 85 feet per second. Up to now, I have given you the equation. Now you have to find the equation. You need to write this down. In fact, I forgot a t. I'll tell you where to put that in. The formula you need to write down is h of t equals negative 16t squared plus v sub o t, goes right there, plus h sub o. I'll write it again. So all we have to do is, this is going to be our original velocity, or our velocity at time 0. This is going to be our original height, or our height at time 0. So the first thing says, write a quadratic function that represents the height h of the ball t seconds after it hits the bat. So I'm going to say then that h of t, that means the height, is equal to negative 16t squared plus, now we have to plug in for the velocity and the height. So what is the initial velocity? 85 t plus, what's the initial height? 4. So now I have enough information right here to write the quadratic function. What about if I had dropped the ball? What would be the initial velocity if I drop it? Like right here at the very beginning, what's its velocity right now? 0. So the initial velocity is always 0 if something's being dropped. When is the ball 110 feet off the ground? Well, where am I going to plug in my 110? H of t. So I'd have this. This might be a time to use the calculator. So I'm going to put in 110, and I'm going to put in negative 16x squared plus 85x plus 4. And I want to know where these equal to each other. If I do a zoom 6, it's not going to look very good. There it is. So I can see it going up and going down, but I want to change my window. I got to go a lot higher than that, maybe up to even 200. Oops, there's my 110. Here comes the parabola. Okay, that's better, isn't it? So we're actually going to have two answers for when it's 110. So I have to do second trace, calculate, intersect, get over there close to it. And so right here at 2 seconds, then also at 3.125. How would that be the case? Why do I get two answers there? Yeah, it's got to go up and it's got to go down. So we're going to have two of them, 2 times. All right, let's go on to the last one. The catcher catches the ball 6 feet from the ground. How long is the ball in the air? Where do we plug in the 6? And for what? H. So it goes back into here, just plug in 6. See if you can solve that now on your own. Okay, so do you guys have some answers? I'm going to show you how I could check them with my program. All I did was I subtracted 6 and I got this equation. Now I can go to program and I can run my program. A is negative 16, B is 85, C is negative 2, and I got these two answers. And it asked me, how long is the ball in the air? Would the catcher catch it on the way up or on the way down? On the way down. That would be weird if he was able to go like that. So that's going to be 5.29 seconds. Is that what you guys got when you did it on your calculator the other way? Actually, we always go up 3 decimal places, so let's make it 5.289. Let's make it that instead. Okay, any questions? All right. So you've got your homework. You can either do it online on Big Ideas or you can do it on paper. It's section 3.4.